did it. Okay, so this is the last video of this lecture. So in step 5, we have to review the algorithm. Now, we need to walk through the algorithm step by step to determine whether or not it will solve the original problem. If it does not solve the original problem, then we know that there's a problem with our algorithm and we need to revisit our steps. But once we are satisfied that the algorithm does provide a solution to the problem, we can ask further questions on that. Does this algorithm solve a specific problem or does it solve a more general problem? If it solves a very specific problem, then how can we generalize it to make it robust? Can this algorithm be simplified? Because in the process of trying to achieve a problem, you'll have probably incurred some ambiguities, some redundancies, and the likes. But simplification is very important because it's going to affect speed of execution. Then, is the solution similar to the solution to another problem? How are they alike or how are they different? If they are alike, then you might just have reinvented the wheel. But if they are different, then you've come up with something novel. And if they are alike, you even the fact that they are alike does not necessarily mean you guys that you use the same method. Then if they are alike, then what you can then do is analyze your method as against the other method to see which is better. Now we have an example. Everything I've been saying, there's an example that we want to use to just wrap it up. It's called pick and plant. Um, it's going to be implemented in Java, but obviously I don't expect that you guys can program Java at your stage. But just follow through and walk through the program. At the end of the day is very simple, just for you to understand the basics of what we've been saying. And for all of you that will maybe take up programming, you can just start from there and to see what it is like. But obviously, we're not going to go into too much of, or at least in my aspects, I won't go into too much of programming. But still look at it, take a look at it. Now, in this example, to complete the algorithm, we need to know that every J rule can up forward, turn left, and right, put a flower from pick a flower from its current location and plant a flower at its current location. Pick a flower from its current location and plant a flower at its current location. But don't forget that current is a function of time. Current is a function of time. You see it when we go on. Now this problem statement, a zero can start a zero starts at 00 facing east with no flowers in its pouch. There is a flower at location 30. Write a program that directs the zero to pick the flower and plant it at location 32. After planting the flower, the zero should up one space east and stop. There are no nets, flowers, or zeros on the island. Well, that would mean that there could be situations like this where we have nets, flowers, and other zeros on the island. But for this particular problem, there are no other nets, flowers, or zeros. Actually, this zero problem was created to introduce new programmers like yourself into programming. You can download it and see and test it out with nets and other zeros and the likes for those of you that would pick up programming like I said that want to be interested in writing programming. Of course, I would expect that for you in ICT you should be able to write programs anyway. So you can make this your starting point. It's actually very simple and very interesting, not complex at all. Now let's start. Here is our zero. Here is the flower. We can see the start and we can see the finish. Zero is at 00 and flower is at 30. You can count each box starts at 0 and you can count it as with 0, 1, 2, 3, 4. Then that's for the rows. Then for the columns, we have 0, 1, 2, 3, 4. So that means that we'll have like 16 boxes. So that will mean the final pot down there will give us 15, 15 if you count it using 0, 0, 3, 0, 0, 0, 1, 0 and the likes. Now At the point of finish, this was planted at point um, 3 2. I hope that's what was requested for us to do. Yes, point 3 2. Now let's see how we got our point 3 2 here. So if you count from the left, 0 1 2 3. I'm talking about the finish now. 0 1 2 3. You can see that the flower is on the third column, and if you count from top, 0 1 2, the flower is at point 2. So yes, that is correct. Then we were asked that the Jeru should face east and up forward from the question. They said after planting the flower, the Jeru should up one space east and stop. So that's exactly where the Jeru is. Now let's start. Now that is our analysis. That's the description of the problem. All I've said around is the description of the problem. You can say I try to analyze what data are available to me. I try to understand. I'm trying to remove ambiguities. I try to make sure that the boxes actually started at 0 and the file is actually at point 30, like we were told it is. If the moment it is not at that point, then clarity has to be solved. Now, analysis of the problem. The flower is exactly 3 spaces ahead of the Jeru. The flower is to be planted exactly 2 spaces south of its current location. Can see when I was giving the example about distance, about all of that would define when I was giving the example about my trouser, getting a new pair of trousers and all. Can see that something similar came up now. The Jeru is to finish facing one space east of the planted flower. There are no nets to worry about. Like they were told us that we shouldn't worry about nets, we shouldn't worry about other Jerus on the island. Of course, like I said, this is a smaller program of a bigger program. We can download the Jeru application and test out with Java skills. You can start learning Java using this application, using this Jeru example. Now, high level algorithm. Let's name the Jeru Bobby. You can name your own Jeru anything you like, and I will give it your name. So Bobby should do the following. Now, this is our high level algorithm. Don't forget that we want to take out complexities from our from want to take out complexities. That's what high level algorithm is all about. Get the flower, put the flower up east. That is clear enough. No complexities. No, we've broken it into 3 parts. That's at the end of the day. And like I said, at the end of the day, but the last step, we must have achieved what we want to achieve, which is up east. Now, detailed algorithm. Don't forget the main in the high level algorithm we identified it as get the flower, put the flower, and up east. So how do we get the flower? Jeru must first up 3 times to pick the flower. After upping 3 times, you're gonna pick the flower. At that time, we've solved the problem of getting the flower. Then to put the flower, Jeru must turn right and up 2 times, then plant the flower. As a matter of fact, we can even break that down into instead of having it at a single line, can have turn right as one point, up 2 times another as another point, then plant flower as another point. Instead of having it just a single statement like I have it here. Like I said, you can always refine it. Keep refining till you get to the answer. Then finally, up east, then you turn left and up once. Now, to review the high level algorithm partitioned the problem into 3 easy subproblems. This seems like a good technique. This algorithm solves a very specific problem because the Jeru and the flower are in very specific locations. The algorithm is actually a solution to a slightly more general problem in which the Jeru starts anywhere and the flower is also anywhere within the area. Don't forget again, I can also have nets, other Jerus on this Jeru island. So, like I said, here is my Java program for pick and plant. So, I'm going to create a public class called my program. Now, Jeru Bobby equals to new Jeru. That means now that Bobby is the name I'm assigning to my Jeru. Like I said, you can at that point if you change that Bobby to any other name, you're going to assign um, the name to your Jeru. Then this does add Bobby. That basically just adds the following steps to the actions that Jeru is going to perform. Now to get the flower, don't forget Bobby can Jeru can up. So now Bobby dot up. And then how many times do you want it to up? 3 times. That's why we pass 3 into that argument. Then we have Bobby dot pick. Pick, of course, pick is pick. We don't need to pass any value into it. Then to put the flower, Bobby dot turn right. Like I was saying, I told you that we can break that step into turn up and plant. When we're talking about the detailed algorithm data, and that's exactly what is done here now. Bobby dot turn right because Bobby was facing east. Don't forget that if you up at that point, then you are going to jump into point 40, and that's not what you are supposed to do. You're supposed to jump into point 31 now. That's why you're supposed to. That's why Bobby needs to turn right. Then it's going to up twice. So once it up once, it's going to fall in point 31. Up a second time, going to fall in point 32. Point 32 are exactly where Bobby should be. Then don't forget, Bobby can plant a flower at its location. Now its current location. Now its current location is what now? Point 32. Then he plants the flower at that point. Then we are good. Next thing is to put up east. If you up east at that point, you're going to be joined into point 33, which is not what you're supposed to do. So Bobby was supposed to jump face east. So the right thing is Bobby dot turn. Then you pass left into Bobby dot turn. If you up at that point, using Bobby dot up, then Bobby is facing east and one space away from where he planted the flower. Then we are done. Thank you for this class. I hope you guys understood all I've said in these 3 videos. I want to so check your WhatsApp. We're gonna have a discussion class where you guys can then ask me questions and I will provide the answers to the best of my knowledge. And we can always revisit anyone that I couldn't provide answers to immediately. So, but you also have an assignment that you will have to submit today. Based on what you have learned in class, develop a simple algorithm for online ordering and delivery of food for students in Bowen University. I don't need the program. All I just need is algorithm, your intuition, your problem solving skills based on the 5 steps of algorithm development that we discussed about. So you're supposed to turn it in today, 10 p.m. I'm going to send it to my email, olarikon.awoniro@gmail.com. So for further reading, you can visit these um, materials. Then let's have discussion for that clarity. We meet after that. Then by next week, expect some other videos for the next lecture. Thank you.